Okay, so we're starting off with this new topic. That is, I think we've done percentages. Yeah, we're on word problems now. Most of the concepts of this topic, word problems, are they're going to be based on the previous concepts that we have already studied, and you'll be required to use most of the concepts of basic algebra to solve word problems. Equations, you'll have to difference now is that you're going to be asked to formulate different equations and then solve them. For example, if x plus 7 equals 2x minus 8, what's the value of x? Now, they've sort of given this in form of a words, and then you just solve it. In 7 years, Erin will be twice as old as she was 8 years ago. How old is Erin now? So now, in this case, you're going to solve a particular equation out of this, then information that you have, and then you will solve it. So, yeah, there are certain terminologies that you should be aware of for word problem related questions: equality signs, addition, subtraction, multiplication, division. Now, for the inequalities as well, there are four types of inequalities that we can work around: greater than equal to, less than equal to, greater than, and less than. Um, this and this are greater or less than equal to together. Unknown quantities denoted by X. Okay. So word problems are gonna be classified into different categories, but for now, let's just look at the basic examples that we have. So first up, in a lottery, 4% of the tickets printed can be redeemed for prizes, and 4% of those tickets have values in excess of $100. If the state prints 40,000 tickets, how many of them can be redeemed for more than $100? So now they're saying that you have a total number of tickets. Let's say the total number of tickets was X because you don't know the total amount, right? 4% of the tickets printed can be redeemed for prizes. Now, out of this X, out of the total number of tickets that you have, 4% can be redeemed for prizes. And then out of those 4% of tickets, 4% more, those tickets can have values in excess of $100. So 4% of these tickets can have values of $100 or in excess of $100. Now they're saying if the total number of tickets printed was 40,000, how many tickets can be redeemed for more than $100 of value? Okay. So now keeping this in mind that X is the number of total number of tickets, 4% of 40,000. This is what we need to understand here. 4% of tickets, four prizes, and then out of those 4%, so the value of greater than $100. So now 4%, you're just gonna quantify it 0.04 into 40,000, you got 64 tickets. So out of 40,000 tickets, 64 can be redeemed for a value more than $100. All right. Acha. Then similarly, the second problem is about ages. In 7 years, Erin will be twice as old as she was 8 years ago. How old is Erin now? So now we're going to start off with present age of Erin, assuming it to be X because that's what you're finding. 8 years ago, she was how much? She was X minus 8 because you're going to subtract 8 from the number of years. And 7 years from now, she will be um, twice as old, so X plus 7. So what we're gonna do is X plus 7 is 7 years from now and twice as old as she was 8 years ago. So what was her age 8 years ago? It was X minus 8. So we're gonna multiply it by 2 because that's they're asking that they're saying that she's twice as old as she was. This is the equation that we have now. You're gonna simply just solve it and you'll get a value for X. So if Erin is, let's say, 23, if the present age of Erin is 23, you can simply put all of this in the equation and see if your answer is correct. So if 7 years, in 7 years, Erin will be twice as old as she was 8 years ago. What was her age 8 years ago? So you can 23 minus 8. You can just check, right? Um, 14. So if, yeah, this is 14. So if Erin is 7 now, so she's gonna be 14. Yeah. Okay. Cha. Now I'm gonna take you to, yeah. So what we do here is for word problems. In this entire topic, we're gonna classify problems into three major categories. Age problems, okay? Then distance problems and time related, I think the percentages, the category that we're already doing, okay? So it's very important for us to understand that all of these problems are sort of categorized. And whenever you come across a question on your exam paper as well, just first of all, think about these three categories that we're dealing with and then apply the relevant solutions. Okay. So now, this was an example of an age-related problem. Okay. This is how all of your age-related questions will be. This one was about a percentage-related question or percentage or finances. Um, Very much similar to ratios and proportions that we did previously. So you're gonna apply the concepts of ratios and proportions, and they haven't given us any example for distance-related problems, so we're gonna get to that separately. Anyways, so let's look at age-related problems. So now we need to remember that all of the problems that involve ages years ago would mean that you need to subtract that number from the years now, from the present age, and years from now means you need to add. So, for example, if X is the number of years, which is the present age, and they say that a person was maybe whatever years ago from this particular age, years ago, may you're going to multiply, assuming that this is the value A, so you're going to subtract it. And if they talk about years from now, so you're going to simply add it. So, just remember these concepts. Now, in 1980, Judy was three times as old as Adam, but in 1984, she was only twice as old as he was. How old was Adam in 1990? Okay, we need to understand a few things here. Dono की ages in all across these years, ठीक है? In 1980, Judy was as old as Adam, ठीक है? So, if look at this table, in 1980, if Adam was X years old, Judy was three times as old as Adam, so it's going to be 3x. Okay. In 1984, she was only twice as old as he was. So if Adam was, because Adam was X years old in 1980 and 4 years later he's going to be X plus 4. So Judy was twice as old as he was. So we're going to add Judy's age to um, we can also sort of figure out Judy's age 4 years later. अभी equation नहीं apply करते. 3x plus 4, why? Because 4 is the number of years that have passed, okay? So 3x plus 4. Now, we know their ages in both of these years. Now we need to figure out certain equations जिनसे हमें मिल जाए how old Adam was in 1990. So we need to find out a value for x, right? So we need to apply a certain equation because you see now you cannot directly jump onto the age of their age in 1990. You will have to find out a way to figure out this value of x, age of Adam in 1980, because obviously you're going to add 10 and you'll get Adam's age in 1990. Okay? So what is it that's helping us to to form an equation? This data over here. She was twice as old as Adam was in 1984. So we're looking at the data of 1984 and the information that they've given us that Judy age was she was only twice as old as he was. So Adam's age multiplied by 2 is going to give you Judy's age in 1984. Then this is where we'll find a value for x. So if Judy was 3x plus 4 in 1984, Adam was 2 times x plus 4 because this was his age and we're sort of multiplying it with 2. And if you solve it, 3x plus 4 equals 2x plus 8. ठीक है 3x minus 2x x आ गया 8 minus 4 4 आ गया this means that value of x is 4 and now if Adam was maybe x plus 4 अगर हमने यहाँ कर दिया तो Adam was 8 years old for example in 1980 so he's going to be how much in 1990 you're going to just add um एक second yeah 8 years ठीक है no sorry 4 years x की value 4 है 4 years in 1980 so you're going to add 10 to it 14 years in 1990. That's the answer. You see, we had to figure out one of the ages. Either we could have figured out the age of 1984, yeah, 1980, and just add the number of years to get 1990. But for that, it was important for us to have a value for x. Guys, is this clear to all of you?
Just
Yes.
explain this again.
All of it?
No, like just an overview.
Sure. Okay. Now, let's do this again. You need to first of all understand कि यहाँ पे what's happening. For their ages, just know their present ages and the ages 4 years later, the data that they've given us. For this, it's important for us to know okay, what their ages were in these 2 years that they're talking about. They're talking about 1980 and they're talking about 1984. Okay, so they're saying for 1980, the data is that Judy was 3 times as old as Adam. So if Adam was X years old, Judy was 3X years old. This she was 3 times as old as Adam. So we've written that in the table. Adam was X years old and Judy was 3X years old. If they were, if this was their age in 1980, what will be their age in 1984, 4 years later? You're gonna add 4 years, right? 4 साल add हो जाएंगे, simple. So if it was X, it will be X plus 4. If it was 3X, it's gonna be 3X plus 4. Umama, यहाँ तक, is it clear?
Yes.
Okay, now that you know their ages in these 2 years, 1980 की age भी हमें पता है, 84 की age भी हमें पता है. We need to find out Adam's age in 1990. But for Adam's age in 1990, we need to know Adam's age in 1980 and 84 as well. तभी हम बता सकेंगे how old he will be in 1990. So this is where a formula will help us. And to arrive at that equation, this information is the biggest hint that we have in this question. She in 84, Judy was only twice as old as Adam was. So we'll look writing down this data in form of a mathematical equation because this will help us find out a value for x. In 1984, Judy was what? She was twice as old as Adam was. That means if you multiply 2 with Adam's age, if you sort of um, get Adam's the twice of Adam's age, that will be the Judy's age in 1984. So 2 times Adam's age is going to be equal to Judy's age in 1984. Now, what was Adam's age in 1984? It was x plus 4. So now we're writing down all of these values that we have x plus 4, and Judy's age was 3x plus 4. But this 3x plus 4, imagine that this was one age, and x plus 4 is one age. This 3x plus 4, one complete age, x plus 4, one complete age. This is, we're sort of fitting this into this particular equation that they've asked us to make. Now, once you solve it, if you solve this equation, the value for x will be 4. So that means Adam was 4 years old in 1980. So how much will he be in 1990, 10 years later? 10 साल बढ़ जाएंगे, right? X plus 10, sorry, 4 plus 10. It will be 14. So C is the correct answer option. Now, does it make sense, Umayma?
Yes.
Okay. Also, guys, if you get stuck anywhere in the explanation, like whenever I'm explaining, and you think that you cannot follow, please stop me there. Okay? It's very important that each one of you understand these examples. अगर आपको नहीं समझ आ रहा और आप पूछ भी नहीं रहे तो trust me, you're doing bad to yourselves. Just stop me there because आपको ये समझना बहुत जरूरी है इन questions को. Okay, distance problems now. For distance problems, it's important for us to know certain formulas, rate into time, rate distance over time, time distance over rate. Rate could be referring speed as rate over here, okay? So, keeping these formulas in mind, how much longer in seconds is required to drive 1 mile at 40 miles per hour than at 60 miles per hour? Okay. 40 miles per hour is the rate, and 60 miles per hour is also the rate. They're saying if you travel at this rate, what is the first rate? It's 40 miles per hour. If you travel at 40 miles per hour, or if you travel at 60 miles per hour, how much longer is it gonna take for you to travel at this speed? Obviously, if you're gonna drive a car slower, it's gonna take you more time. So they're asking how much longer is it gonna take you in seconds if you travel at this speed rather than traveling at this speed. Let's call 40 miles per hour as speed A and 60 miles per hour at speed B. यहाँ तक तो समझ आ गया होगा कि traveling at 60 miles per hour is going to take you less time. Now let's look at the equations that we can make. For time, 1 mile over 40 miles per hour, we're going to use this formula, distance over rate. If distance is 1 mile, okay, so rate is 40 miles per hour. उसमें time कितना लगेगा? 1 upon 40. You can convert this into 60, into minutes. So it's going to be 3 upon 2 minutes, 1 whole 1 by 2, which is 1.5 minutes. 1 complete minute and 1 half minute. This is the time that, and if you convert this entire thing into seconds, so 1 minute is 60 seconds and half a minute is 30 seconds. So it's going to take you 90 seconds to travel 1 mile at the speed of 40 miles per hour. This is the time, this is the equation, and we solved it to 90 seconds. Are you guys following me? Okay. Now, if the speed was 60 miles per hour, the same 1 mile, to travel the same 1 mile, you would have traveled in 1 minute. That's 60 seconds. So how much longer are you taking when you're traveling at a slower speed is 90 minus 60, which is 30 seconds. So you're taking 30 more seconds if you're traveling, if you're driving at maybe 40 miles per hour than driving at 60 miles per hour. Clear, guys?
Yes.
Okay. Mark drove to a meeting at 60 miles per hour. Returning over the same route, he encountered heavy traffic and was able to drive at only 40 miles per hour. If the return trip took 1 hour longer, how many miles did he drive each way? Okay. अब इसमें भी समझने की जरूरत है. When Mark was driving to a meeting, okay, let's figure it out. A, let's say this is the starting point, and B is, let's say, the point where he has a meeting. Okay, he drove at 60 miles per hour. जाते वक्त his speed was 60 miles per hour. Okay, returning over the same road, he encountered heavy traffic and was able to drive at 40. So when he was coming back to the meeting, he drove at 40 miles per hour. If the return trip took 1 hour longer, how many miles did he drive each way? Now, if let's say he drove time t in hours, let's say he drove t hours while going to the meeting, and it took 1 hour longer, so we can say that it took him t plus 1 hours when he was coming back. So now we know the rate and we know the time. ठीक है, जाने आने का दोनों का rate और time पता चल गया. They're asking how much miles did he drive each way? They're asking us to find out distance. So distance is what? Rate into time. Using this formula, distance equals rate into time. What we're going to do is we are going to pick up these values. Rate was 60 when he was going, okay? When he was going, the rate was 60 and the time was t. So we've got 60t as the distance. And when he was coming back, it was 40 into t plus 1. So 40 times t plus 1 is the distance when he was returning. And we have the data, right? The outbound journey, 60 rate, t times 60t distance. The inbound journey, 40 rate, t plus 1 time, and 40 times t plus 1 distance. How much did he drive altogether now that we know the distance going to the meeting and distance coming back from the meeting is equal? He's traveling at the same path. So we're going to use both of these formulas, equations, and we're going to equate them. Because zahir hai, distance तो उतना ही लगा है ना. So this is what we're doing here. 60t equals 40t plus 1. Now if we start solving it, 60t equals 40t plus 40. यहाँ पे solve हुआ है नीचे. Let's use this. So you get time as 2. Now once we know the time, which is 2, so you're going to put this time instead of t over here. 60 into 2 is 120. यहाँ भी करें तो ये आंसर रहेगा. ठीक है, 40 times 3 is also 120. So he drove 120. All clear, guys? Now, the next type of problems. Just a second. Okay. So example number eight. At 8 p.m., the hostess of the party remarked that only one-fourth of her guests had arrived so far. But that as soon as 10 more showed up, one-third of the guests would be there. How many people were invited? Okay. 8 p.m., the total number of guests was 1 by 4. Let's say if the total of guests was X, so 1/4 of X were there. Um, when 10 more people arrived, the total number of guests reached one-third of X. They're asking what's the value of X, the total number of people that were invited. So can we say that if 1 upon 4 of X was the number of people at 8 p.m., and when 10 more people came, the value quickly touched one-third of X? Do you guys agree with this equation? Guys, are you all awake?
Yes.
Okay. All right. Let's solve this equation then. X तो यहीं से मिल जाएगा हमें. Equation तो बन गई हमारे पास simply. कैसे करेंगे? Let's bring all this together. 1 4x minus 1 by 3x equals negative 10. 12 हो गया. LCM ले लेते हैं. 3x minus 4x equals minus 10. 3x minus 4x is minus x equals minus 120 minus minus 1 x equals 120. So 120 people were invited at the party. Got it, guys? Should move forward.
Yes.
Okay. Now, in a family of three, the father weighed 5 times as much as the child, and the mother weighed 3 by 4 as much as the father. If the three of them weighed a total of 390 pounds, how much did the mother weigh? Okay. The weight of father was 5 times as much as child. Let's say if the weight of child was X, father's weight would be 5X, and mother weighed 3 by 4 as much as the father. So mother's weight was 3 by 4 of 5X. It was 3/4 of 5X. Now, if the three of them weighed all together, how much? 390 pounds. How much did the mother weigh? तो हमें यहाँ से x मिलेगा, फिर हम x से जाके we're gonna find plug in the value. So the combined weight will be x plus 5x plus 3 by 4x into 5x करने के बाद आपको ये 15 by 4x मिल जाएगा. ठीक है? You formulate this equation. All of it equal to 390. इसमें आपके पास you're gonna get a value for x. X will be 40. Now when x will be 40, we're gonna plug in this in the age in the weight of the mother, the equation that represented that weight, right? So 3 upon 4 into 5 times 40 equals what that we're finding. Okay, 5 fours are 200 हो जाएगा यहाँ पे. 203. 600 divided by 4. 150 pounds. Yeah. ठीक है. We can do this last example before we head on to the assignment. A teacher wrote 3 consecutive odd integers on the board. She then multiplied the first by 2, the second by 3, and the third by 4. Finally, she added all 6 numbers and got the sum of 400. What was the smallest number she wrote? Okay. 3 consecutive integers could be, the first one could be n, the second one could be n plus 2, and the third one could be n plus 3. 3 consecutive होंगे ना, अगर ये 1 होगा तो ये 2 होगा, ये 3 होगा, 2 होगा, 3 होगा, 4 होगा. n plus 2 अब आगे क्या है इसमें? What was the smallest number she wrote? Okay. Um, Odd integers हैं. Okay. So consecutive odd. So it will be n plus 4. तब odd number मिलेगा आपको. Once you have this, these three different expressions. You're going to add them and equate them to 400 because this is the sum. n plus 2 n plus 4 इक्वल किया तो आपके पास आ गया 400 और फिर n की वैल्यू मिल जाएगी सिंपल. Guys, remember for integers, representation is very important. n, n plus 1, n plus 2, n plus 3. This sort of representation can be used for any consecutive integer. But when you're specifically talking about even or odd integers, it's important for you to know that I'm counting देखते हैं 1, 2, 3, 4, 5, 6. See, 2, 4, 6, they arrive after every one extra number, right? So if n plus 1, if let's say n is 1, so n plus 1 is going to be 2, n plus 3 is going to be 4, n plus 5 is going to be 6. So you add all odd numbers to get even integers. Similarly, if you add all even numbers, n plus 2, n plus 4, n plus 6, you're going to get all odd numbers. Um, Considering that the value of n is 1. So please be mindful of integer representations when you solve such questions. We're here at the assignment. Now, I had initially planned okay, we're gonna do topic 1 of module 3 and topic 2 of module 3 as well, but because this word problems topic is a bit challenging, so I'm gonna leave you guys with the assignment right away, and we're not gonna do anything else for this lecture. Um, you have 30 minutes to submit this assignment. The meeting is gonna stay on. I think that because of the time limit, it might end 7 minutes, but I will send you guys another link and you'll have to join that. So submission time is exactly 3:10 p.m. And guys, please start working. The document is there in the group as well. Clear to all of you?
Yes.